welcome in. So a grade 12 advanced function. So here we go. It's a little mini test for you on rational functions. There are about 5 questions here that you will find. So as usual with all of these tests that I create, I'll put up a downloadable link, okay, in the show notes. You can click on that, do the test, come back, and then see the solutions here. Okay, so let's get started. Okay, so question 1. So in question number 1, I'm going to just kind of copy it, bring it down. Let's see what this one is all about. So for the function, okay, so b of t is equal to 2 over t plus 1 over t plus 10. So it clearly is a rational function. Find the average rate of change on the interval, so 1 through 8, and then b, find the instantaneous rate of change at t is equal to 3. So the only thing that we have to be careful, obviously, so within kind of the intervals and then the instantaneous rate, we don't want to have any undefined items. And notice that t is not defined for 0, and then t won't be defined for -10. But other than that, we're pretty good. Okay, so that means that interval that we're looking at is fine. So let's take a look and see if we can find this average rate of change on that interval. So that's what we're going to try to find right here. Okay, and I'm going to go ahead and do it. So our interval is 1 through 8. So on average, so what we want to be able to do is the following. So this is for A. So we want to take B at 8 minus b at 1 divided by, so this is just finding the average rate of change. So that's going to be 8 minus 1. So that's going to be 7 in the denominator. And now let's take a look and see and plug this whole thing in. Okay, so I'm going to plug in the 8, plug in the 1, and then try to simplify it. So I'll do it in fast forward fashion for you, and then we're going to see what the answer will be. All right, so welcome back. So here it is. Here's our answer. So it looks like it's negative. Okay, so the average is negative right here. And here it is in terms of, I mean, you can actually see it on the screen there in the calculator. So you can round it up. I rounded it to 3 decimal places there. So it's negative 0.255. So that's the average, okay, rate of change on that interval. Now, if we want to find the instantaneous rate of change, so that is at a particular point. So this one, won't be as easy, I guess. So that's for B. And what do we have? We have it at t is equal to 3. Okay, so we're going to copy this again. I just want to have it in front of me right there. And in order to find the instantaneous rate of change, so what we need is, so I'm going to be using B. All right, and this was at 3. So 3 plus h. So my h is a very small, little number, okay? And then my hope is to try to make it as close to 0 as possible, right? So minus b at 3 divided by, okay, our h. So I'm going to try to see if I can simplify this as much as possible. Again, I'll do it in fast forward fashion. So I'll plug it into our function, and then we'll see what the actual instantaneous rate of change is. And that's all that they want. All right. All right, so let's say that, okay? And notice that as we make it smaller and smaller and smaller, okay, so it looks like our instantaneous rate of change, okay, so notice that right here. So this is if we were plugging into a calculator, right? We plug in 0.1, we get 0.220, so on. We make, okay, our h, okay, even smaller, okay, make it even smaller, make it even smaller, make it even smaller. So notice now it's starting to approach. So it is approximately negative 0.22, let's say 8. I'll just keep it to 3 decimal places. So that would have been our instantaneous rate of change for this one. All right, and you can use decimals to your advantage, or you can take out your calculator, plug it all back in, use a very small h and you'll get the same result. Okay, so that's question number 1. Copy, let's paste it below. So I'm going to have that. Okay, so for now this function, so 3x plus 5 over 2 minus x, so right away, this reminds me of this, right? So this is this format, cx plus d. Okay, so we can certainly try to figure this thing out. So for that function, find the domain and the range of the function, okay? What is the average rate of change? Okay, between 3 and 5. Find the tangent line. Okay, so tangent line, so with the slope and intercept, and then sketch the function. All right, so we can certainly try to do that with these ones. We do have the tools. So first of all, we got to be careful here. So we do have a 0. I'm going to try to do all of this kind of at once. So, even from the sketch, I like to sketch to try to see how this thing looks like. So we have from the denominator, so from right here, so it looks like we have a 0 in the denominator at x is equal to 2, which means that this thing is going to be undefined, right? So that's going to be a vertical asymptote for us. So that's a vertical asymptote. Now in the numerator, so our 0, so right here, so that's going to be x, I guess, is equal to, if we change that over, so minus 5 over 3. Okay, so notice these are different. So it is indeed a vertical asymptote and not just a hole that we would have. So that's a 0 there. So that is, that function crosses at negative 5 over 3. Okay, so that's fine. So now let's try to see if we can graph it out. So we'll have, I'm going to just put this in here. All right. And let's draw this out like this. Okay. I'm going to try to copy this and so I can have it in front of me. Okay. And then we can talk about domains and ranges and so on. So here we go. So at 2, if I plot this, so this is at 2. So I have a vertical asymptote, so that's like this. So it's undefined at that point, and that means it's defined everywhere else. All right, so it's going to cross at negative 5 over 3. Okay, so somewhere there. So negative 5 over 3, so let's say this is negative 5 over 3, something like this. All right, now we do have, and so notice in here, okay, so from this right here, we're going to have a horizontal asymptote. So horizontal asymptote. So on the right hand side, as x gets bigger and bigger, so that is going to be negative 3 over, sorry, this is actually negative 3. So negative 3, right? So that's coming from, because, so we're going to, so 3x plus 5 all over 2 minus x. So notice these two things are gone, because if x gets bigger and bigger and bigger and bigger, the only thing that dominate is this and this. So the x's cancel and you'll get negative 3. So it looks like we have a vertical asymptote at negative 3. Sorry, horizontal asymptote. So that's going to be going in this direction. So we'll see what's happening there. So how it's approaching it. Is it from the top, right? Okay, or is it from the bottom? So we're going to see that soon. Now on the left-hand side, if it's negative, then what we're going to get there. So on the negative side, so it's still going to be, so as the numbers become bigger and bigger negative, so it's still going to be continuing for us. So it's kind of like this. So let's let's see what happens there. Now we know that it's crossing at -5/3, right? So it's a 0. So that means, you know, something is going to be happening there, okay, with respect to that. So, you know, my guess, because it's -3 as the asymptote, so it's going to be probably something, you know, something like that. And then it's going to swing out this way. Okay, so that's going to kind of sketch out that way. And then let's take a look and see, okay, at this point. So let's say at 3, you know, on which side is it? Is it on this side or is it going to be on the bottom side? All right, so we'll try to do that. And then we can obviously get closer and closer to 2, okay, and see if it's, you know, how it's approaching it. But I first want to see what happens at 3. So 3, it's going to be 9 plus 5 all over 2 minus 3. So what is this going to be? 14 all over -1, which is -14. All right, so that means, okay, so with, you know, all of this stuff, okay, I'm going to shift this out right here. So -14, so notice that this, as it continues on, so -14 is going to be somewhere over here. So it looks like it's going to be something like this. Okay, it's going to be going, okay, down in here. All right. Now, because if it was going in the opposite direction, so, you know, if it was trying to go up, okay, like this, right? So it would have basically have to look something like that. So it would have to make a turn back because that's the horizontal asymptote. But that's impossible because it would have to cross through here through a 0. And we don't have any zeros on this side. So that's why this, okay, right here is going to look of that nature. All right. And then on the opposite side, so right here, again, so towards the negative, so if you go further and further out, okay, on the negative side, so that -3 right here, okay, you know, how do we know it doesn't look, you know, so if it's in terms of the crossings, you know, how do we know that it didn't go something like this, for instance, like this, okay, crossed back, okay, or something like that. Okay, well, we know that that can't happen because we have 2 zeros, but we only have 1 in our function. So this can't really happen, doesn't really make much sense. And now you can also check, so notice on here, when it's 1, if I plug in 1 into here, so I'm going to get 3 plus 5 over 2 minus 1, notice 8 over this, so it's positive. So it's definitely something over there, okay, that it's heading towards. And then because of the horizontal asymptote, so this is going to be heading through here. Now, the question also might be, you know, does it pass through this -3? You know, does it eventually go like this and then come back, right? So that's another thing, you know, that we have to kind of worry about, that, you know, does it stem out, come back in? Now, this is first order on top and then first order at the bottom. So those swings, okay, that you see, they don't really happen on the first order polynomial on top and first order polynomial at the bottom. Okay, now if you're also kind of worried or curious, just take a few. So here, you know, plug something at -2, plug something in at -3, okay, you know, do a few dots, and then you'll see that it's going to be heading towards, okay, what we need. Now, just out of this, we can pick off what the domain is. So the domain for this entire thing is basically all of x, right, except at 2, because we have a vertical asymptote. The range, on the other hand, okay, the range is basically all of y except at -3, right? So -3, it actually never reaches -3 because it's a horizontal asymptote. So that's my range, that's my domain. Now, I know that it said calculate the average rate, okay, and then define the tangent line. We'll do that. But I also want to, I'll pop up Desmos and just kind of show you. So what do we had? We had f at x equals, it doesn't tell us to use Desmos, but, you know, since I'm doing the solutions, I just want to kind of show you. So look at that, okay? So notice this is exactly what happens, right? So here is, so it's going to be tending towards that 2, goes up and tends towards the 2, okay? That's exactly what we've drawn, and then it goes in here, okay, and then tends, and notice it's supposed to be towards the -3, right? So -3, where's -3? Here, okay? And if we scroll in, notice that it just gets closer and closer to -3, okay? So perfect. Now, let's see what we have. So our average rate of change is between 3 and 5. So I'm going to remove this. So between 3 and 5. So this is for B. All right. Okay. Between 3 and 5. So we have F at 5 minus F at 3. So that's going to be our average over 5 minus 3. So that's 2. Now substituting this in. Right, so don't forget. So this is, sorry, it's 3x plus 5 all over 2 minus x. So how does this look like? Okay, we have, so 3 times 5 is 15. 15 plus 5. So I'm going to do that actually in fast forward fashion. I'll be back. All right, so here's our average rate. Hopefully that's correct, okay? If anything, you can put up a comment, okay, below. And then they asked us also for find the tangent line at x is equal to 0. Okay. Okay, so at x is equal to 0. So here it is. We have, here's our of x equals to 3x plus 5, 2 minus x. So we need the slope, right? And I guess we'll need the y-intercept. Well, at 0, actually, what is it at 0 here? This is going to be 5 over 2, right? 5 over 2, which is 2.5. So that's at f is equal to 0. Okay, so our point, so this is 0, 2.5, so that's one of our points. So let's say 0.1 that we have. Now we want to know the instantaneous rate of change because we're finding the tangent line. So I need to find here, so this is going to be f, okay, at 0. So 0 plus h minus f at 0, which we already know from above, all over h. So what is this? So and hopefully it's a little bit easier. So this is going to be 3, substituting, so h plus 5 all over 2 minus h minus, I guess this is 2.5 because it's at 0, which we just found. Right, so this whole thing over h. This time I'm going to simplify. This should be doable. All right, so let's take a look what this gives us. All right, so here we go. So that's basically our slope. So that's our instantaneous rate of change. So around 2.75. And I just manipulated the h. Notice the h is canceled. You can try it, right? Or you can, find the h, okay, by making it smaller and smaller and smaller, and you'll see that it'll basically get you to 2.75. So our tangent line is going to be 2.75 x, and our intercept at 0 was 2.5. All right, so we needed a point. So we had, so that was the actual point, and it's because it's at x is equal to 0, right? So it's exactly, okay, through the y-intercept because it's at that particular point. So we have, that would have been our slope. Now, let's plot it in here. Let's see how it will look like. Okay, on top of our graph. So y is equal to 2.75 x plus 2.5. And notice beautifully the tangent goes in. Look at that. All right, so that's our tangent line that we had. And so I think that takes care of question number 2 for us. So we found the domain, found the range, found the average rate, the tangent lines, and we sketched it. Again, we also seen the sketch here. So that's question 2. Let's take a look at question 3. Here is question number 3 for us. So given the polynomial function, this is a cubic, okay? Sketch the function. Okay, sketch the function. And then sketch the reciprocal of g of x. Okay, so this is, so the reciprocal, you know, if we were doing this, then really what we wanted to know is what is 1 over, well, let me just write it like this, 1 over g of x. Okay, and we, I guess if we sketch the actual function, so this one, this polynomial, then it's so much easier to try to sketch this, right? Because of reciprocals, you know, so what we see, you know, so we're basically going to be using, you know, that g of x multiplied by 1 over g of x is equal to 1, because that's what a reciprocal gives us. So we're going to be using that. Now, if you forgot about those reciprocals, I guess I'll put up a link up above there for you, okay, to the video that actually discusses these types of examples. So we're going to have to try to plot this out. I just hope we can factor this in some way. Okay, so let's see if we can factor it. So g of x equals, so in factoring, I'm going to be guessing here. So 0 won't work because we have the -2 at the end. About, I don't know, let's try 1 plus 2 minus 1 minus 2. Oh, that works. Okay, so that's one factor. So x minus 1 is going to be one factor. Well, now it's the annoying part. We need to, you know what, I mean, we can do long division. Okay, if I do long division here, let's see what we will get. Hopefully it's something factorable further. X squared plus 3x plus 2, so quadratic. Well, I guess it's going to be x plus 1, x plus 2, right? So this equals that right here. Okay, so this is actually fully factorable. So g of x is going to be equal to, let's put this x plus 2, and then x plus 1, and then x minus 1. Okay, so well, if we have this, then it's much easier to try to sketch. Notice they're all in first order. So what do we know? It's a cubic. So we know it's going to look, you know, cubic, something like that, right? Because here in front it's positive, so it's going to be of this nature. That's on the extremes. Now these are all my zeros here. So let's try. So this brings us back to these sketches and then how they look like. So I'm going to try my best here. Okay, so we have 1 at 1. We have 1 at -1. We have a 0 at -2. Okay. So, and now it looks like this on the ends, right? So right here. So we know that right here it's going to go through. Okay, going to follow like this. And right here it's going to follow like that. Okay, at -2, notice this is of order 1, so it's basically like a straight line right there. Okay, and so here it's also a straight line, so this is going to be something like this. Right, that's kind of how it's going to look like that. Now these peaks, right, they're not exactly in the middle, in between there, and we don't know exactly how high this is, you know, or how low. So these peaks are going to be switching, you know, here and there. But in terms of a sketch, this is what it would look like. All right. Now with this, so that's our g of x. Okay. Now, so let's, you know, so that's going to be our g of x. So that's our sketch. All right. If we bring back decimals, Okay, so let's close these guys off. Now our original. Okay, make sure. So this was g of x was equal to, that's our polynomial, x cubed plus 2x squared minus x minus 2. Haha. All right, so it looks exactly, that's beautiful. Okay, so it looks like that. Now, reciprocal. Okay, so now for the reciprocal, to sketch it, so we can, right, so how is this going to look like? Here are our zeros, right? Sorry, 0, 0, and 0. Okay, so for our reciprocals, so what do we know? So if I graph this again, I'm going to try to do this. I'm going to try to duplicate, put it just underneath, all right? So these are our zeros. Remember that at these zeros, 1, 0, we had another one right here, so that's at the 1. Our reciprocal is undefined. Why? Because if you go 1 over g of x and then you have a 0 here, then it's 1 over 0, which is undefined. So that means at these points, it's blowing up on us, right? So it's undefined at those points. Now we have to see what's happening with regards to 1 over g of x. So if it's blowing up on us, so it tends towards, now it's, so the results here, right here, so this is all negative, right? Now our g of x, so if I put g of x in its factored form, x plus 2, okay, so it's going to be, so this is 1, right, all over, and this is x plus 2, x plus 1, x minus 1. All right, so on the negative, so to the left of negative 2, so what's happening here? So notice that this is getting bigger and bigger, okay, in this direction. So as we're tending towards the negative side, right, it's getting bigger and bigger negative for us. So this entire thing, right, is going to be getting bigger and bigger negative. So 1 over a negative is still a negative, right? So this is going to be blowing up on us, okay? And that means that this thing is going to tend, so this whole thing, because it's 1 over a very big number, it's going to be tending towards 0. So it looks like this thing is going, it's kind of going to go like this. And on the negative side, so it's blowing up on us right here, right? So it's going to go like this. As it gets closer and closer to negative 2, this thing, so if you're going in this direction, notice it's getting smaller and smaller and smaller and smaller. So 1 over a small number is a big number, but it's at the bottom in the denominator, it's negative. So that's the sketch for that side. Now, for this side, okay, so for right here, so if going from here to here, so it's going to be, it's on the positive side, so it blows up on the positive side, so it's going to be like this, right? And then again, it's on the positive side, so it's going to be blowing up like this, so it doesn't go negative. Now, at this point, okay, it has a bottom, right? So it's going to peak out, okay, at that local maximum there. It's going to peak out somewhere over here, okay? So it's going to be the same thing with regards to that, okay? So that's, if you're looking at Desmos over here, right? So that peak, okay, you know, it's going to peak out at exactly the same point. So, I mean, I'm just sketching it. I don't know exactly what that number is. I mean, here in Desmos, I can see it. But if you're sketching, you know, you won't necessarily know what that might be. Okay, so within that particular peak. And now moving over to the next one. So on this side, so this is all negative. So if this is all negative, and again, so you're going to have a peak somewhere there. Okay, so that's on this side. So if you're looking, there's a peak somewhere over there. We don't know exactly where. Okay, so it looks like it's somewhere over here. But if you were sketching, you wouldn't have necessarily known that. But what you do know is that it blows up on this side, right? And it blows up on here, and it's on the negative side because all of this is on the negative side, and then it gets closer to the zeros, and then I guess it's going to peak somewhere over there, right? Now, how you drew it, where that peak happens, if you were sketching, I mean, your teachers should be kind of forgiving you unless they really want you to do a lot more work. And then on the right-hand side, so notice that this is all positive, so back to all positive, and this is getting bigger and bigger and bigger. So on the positive side, so this is going to look like this, like that. So that's your inverse sketch. So this is awesome. Let's take a look and see. Ooh, 1 over g of x. All right, so there you have it. So our sketch was right. Okay, so that's how it looked like. So that's the purple that you see there. You can see them side by side. My sketch is not very pretty, but okay, it certainly looks kind of like that. All right. Okay, so that is another question out of the way. All right, so question number 4. So here it says find all the holes, vertical asymptotes, horizontal asymptotes, and slant asymptotes if they exist. Okay, and then we want to sketch the graph. Ooh, sketching again. Okay, so let's take a look and then see, okay, how would we approach it? So we do have to know and kind of see for holes, what do we know with rational functions? Well, we know that there has to be a 0 on top, 0 at the bottom, so they cancel off. That's going to be a hole. Vertical asymptotes, we know we have to look in the denominator, right? Horizontal asymptotes, we have to kind of see what happens as you tend towards infinity, okay? And then we'll see what that is all about, and then slant asymptotes. And now if you forgot it, all of this, well, I'm going to put up a link up above there for you so that you can review it. But let's take a look and see what we're going to get. I hope this is factorable as well. So, so 2x. Now, x squared minus x minus 6. So I'm just kind of looking, trying to see. It's a quadratic. What would this be? 2 and 3, I guess. Maybe x minus 3 and x plus 2. Yeah, that looks like it. So x squared, so minus 6. Yeah, all right. Ooh, okay, so that was factorable. So we have that. Now in the denominator, I have no idea. That's factorable as well. X squared minus 4x plus 3. So that's, 1 time. So that's 3. Oh. X minus 1, x minus 3. Right? That's going to give us that. Yep. Okay, so we have that. Okay, so we do see, so there is a hole right here, because these two will cancel for us. Okay, so if they're going to cancel, then it's so much easier to graph. All right? But, okay, so this gives us, so we have a hole here at x is equal to 3. That's going to be an empty spot there when we're sketching it out. Now, if that happens, okay, so now we don't have to worry about that. Now, that also means that the domain does not include 3. Now, okay, so from there we have 2x, x plus 2, which is much nicer to work with, and then x minus 1. All right. Okay, so here's your vertical. So that's going to be your vertical asymptote. So that's going to happen at x equals to 1. Right? Now notice the numerator is 1 degree higher. So what we're going to have is we're going to have a slant asymptote happening there. We're going to have a slant asymptote and not a horizontal asymptote. Okay. All right, so we have a 0. Okay, so 0 on top at x is equal to 0, and then at x is equal to -2. So we have 2 zeros there. So those are going to be crossing through zeros and an asymptote right here. Well, let's try to graph it or sketch it. So those are going to be all of the pieces of information for us. So what do we have? Okay, so at x, at x is equal to 0, we have a crossing there. At x is equal to -2, so -1, -2. So we also have a crossing there. So that's what we have in here so far. Now, at x is equal to 1, okay, so I'm going to just blog these up. So we have a vertical. It's a vertical asymptote going through right there. Okay. And now we know we have a slant asymptote. So as x gets bigger and bigger and bigger, all right, so here's our slant asymptote. So that's going to be 2x squared plus 4x all over, okay, x minus 1. All right. So if x gets really big, right? So as we're going through this and x gets bigger and bigger and bigger and bigger, so notice that. So this thing tends towards infinity, right? So one of those, so that x, okay, so it's going to cancel that off in one of these. So it looks like we have a slant kind of approaching this, right? 2x plus 4. So looks like it's going to be some kind of a slant, going through that. So we're going to see how the heck we're going to deal with those. Okay. So that's 2, that's 3, that's 4, okay, and so on. Oh boy. Okay, so how do we work through these? Okay. So now sketching this out, okay, as we're going through here. So we know we have the 2 zeros, right? So those are not going to be fun to work with. So we have kind of different things that we have to worry about. So first, let's worry about everything what's happening here, okay, up to this point. So at -2, what's happening at that particular end. So when it's -3, -4, negative, and so on. So we know it's going to cross through here, and we know that so here's your horizontal asymptote, okay, right there, as you are heading through that. So let's see how that would work on that side. So that's negative. I'm just thinking out loud here. So this is going to be, let's say, so we have 2x plus 4. I'm going to take out that x, right? And then in the denominator, if I take out the x, I'm going to get 1 minus 1 over x. So as that tends towards 0. Tends towards 0. These cancel. All right, so that's our... Okay, so I have to draw this out. So I have to draw that horizontal, that slant asymptote. So it's 4. Okay, 1, 2, 3, 4. So it's kind of going to go through here. And it's... The thing is, because I'm just sketching, so I know that it's going to go off, right? So it's going to be something like that. I just don't know, does it pass through that? let's see, at negative, okay, so 2x plus 4, the 0 is going to be at minus 2, actually. Is that right? Yeah, it's minus 2, so it kind of slants through that. Okay. So let's see what's happening here. So we have all of these different ranges. So I know we have something here. All right, and then here. Okay, so very close to 1. Okay, let's plug that in. Okay, so if we plug in, let's say 0.9, so 2 times 0.9, 0.9 plus 2, okay, and then 0.9 minus 1, so that's all positive, and then this is very small negative, so that means this kind of goes in this direction. Sketches through here. Now it has to pass through here, right? And then it has to come back. So, right, so it's going to be something like that. Now, let's see how it approaches this. Okay, so we have something of that nature, right? At negative 1, let's see where it is at negative 1. Negative 2, negative 1 plus 2, and at negative 1, this is going to be minus 2. So those cancel, so that's plus 1. Oh, I drew it too high up. It's going to be around a 1, somewhere around there. Something like this. At negative 2, we know that it's at 0. Alright, so it crosses through here. At negative 3, so I'm just sketching it out. Notice that it's not easy. So 2, negative 3. So negative 3 plus 2 is negative 1. Negative 3 minus, so it's going to be negative 4. So it's going to be negative, negative, so that's 6. Right, so it's going to be 6 over negative 4, which is negative 1.5. Okay, negative 1.5, somewhere along there. So it looks like it just goes like this, and then it will eventually just slowly tend toward that. Now on the right hand side, negative 1, or it might just cross. Okay, this is, I wonder if it's above it or below it. So at negative 3, so this is negative, whoops, okay, negative that. So I want to see this in comparison to my line, you know, so when it crosses through here, right, does it cross like this and comes back, or does it go below it? Okay, and so at the line, 2, negative 3 plus the 4, so what is that? Negative 6 plus 4 is negative 2. Okay, which is lower. So this is going to be higher. So it goes through here. So it goes high. So it goes like this. Okay, and then tends towards that. That's what it looks like it's going to happen. Okay. This is kind of fun. So delete. Now on the right hand side, 1.1, so that's going to be on the positive. Ooh, so you know what's going to happen here? So this goes off. Because if we now substitute, let's say 1.1, the top is all positive and the bottom is all positive. So that means this starts to blow up like this, and then it's going to tend towards here because we know that it approaches that. Okay, so that's our sketch. Ha, this is going to be crazy. Let's see it. Okay, we know where the hole is, so the hole happens at 3. So that means at 3, so there's like a hole right here. I'm going to try to bring back decimals. Try to sketch it out for us. Close this down. And what do we have? So this is h of x equals, okay, 2x all over x squared minus x minus 6. Okay, that's all over x squared minus 4x plus 3. Oh, I'm scared to watch. Oh, okay, it worked. Okay, beautiful. So beautiful, beautiful. So that means, if I go here, let's see if all of these things align. Yep, so at 1, we have our vertical. At 3, there should be a hole. Right? Yep, there we go. I saw it undefined. There's our hole. And here, look at this. We have a crossing through the 0, the crossing through the minus 2, right? As it goes on here, and then it just tends towards our asymptotes. Perfect. Okay? So a lot of work, but we got it. So there is a sketch. There's decimals to confirm it for us, to just kind of go through it. Okay, next question. Last one. All right, welcome back. Okay, new attire. Let's solve this last one. Okay, for these rationals. Okay, so rational functions kind of test. This one is an inequality. We want to be able to solve, I guess we'll solve this for t. So we can solve it, basically by hand, and that's what I will do because the assumption is that it's still a test. But of course you can utilize tools. If I plug this into decimals, then we pretty much are going to be able to see what the answer is exactly. But let's see, how would we try to approach this without kind of decimals? So for all of these different inequalities, so, please remember, so that kind of, step number 1 that we want to be able to do is we like to shift everything to one side. So this is what I'll try to do right here. So t minus 10, I guess plus 1 greater than 0. We can simplify, okay, so let's kind of simplify this as much as possible. So we just have numerators and denominators, so I can find a common denominator here. We're going to get 2, so t minus 10 plus 1 times t plus, and notice the 1 at the end there, it's going to be t and then t minus 10 if you put it all under the same denominator. So that's going to be that, and then the denominator is going to be this. All right, so we have that. Now, playing around with this, so let's simplify that. So 2t minus 20, I guess, plus t squared minus 10t. I'm just working with the numerator, so let me just simplify that one. Okay, so t squared and 2t, 3t minus, so that's 7t minus 20. Okay, so that's a quadratic right on top. So we have that. That's not what I wanted. Over, and this is going to be t over t minus 10. So that's what we're trying to look at, right? So now this one looks a little bit better. I mean, obviously it's no fun to do. So we do have to be careful. So t cannot be equal to 0 and cannot be equal to 10. So we're going to watch out for those. All right, just to create our interval. So step number 1, so we've simplified. Okay, so step number 2, we have to find the zeros here. All right. So we're basically solving, so if we want to solve for the zeros, we can take the entire numerator like this. So this is going to be t squared minus 7t minus 20 is equal to 0. So now it's a quadratic. I can't really see I don't think this is a very nice quadratic, so let's just use the quadratic formula. So minus, so b, it's -7, so I guess it's going to be 7 plus minus square root b, so 49 minus 4a, and then minus 20, so that's going to be plus right here. Okay, so this one's going to work. And then 2 times a, so that's 2. All right. Okay, so I'm going to, I guess, do it in fast forward fashion. So I'll just substitute it all in, find out what the two answers are, what the two zeros from these are. All right, so those are our zeros. So they're not very pretty. And I mean, I rounded, so it just still continues there, but that's good enough right there. So we found our zeros. So that means now next, okay, so what we're going to do is, okay, we'll find out what's happening here. And with these, so this is going to be a lot of work. Okay. So, okay, so step number 3, okay, so I like to kind of, draw this number line and then, so organize it here. Okay, so what do we have? What's the one furthest to the left? So minus 2 points, so it's this one. All right, so 1, 7, and so on. Then it's a 0. Okay, so it's 0. That's from here. I guess then it's this one, 9.17, so on, and then it's a 10. So I have to check, okay, so there's going to be a lot of intervals. So I have to check this interval, right? That's 1. Okay, so let's go one by one. Okay, so this is t. So t less than, now notice because of this, okay, so we want to find, so we know that it's zeros at these 2 points, so we can't really include these points, right? So these are the zeros here. So we're going to be looking at what's happening on that. Okay, so with respect to those, so for t less than -2.17, so all we're going to do, so we can pick one. So again, you can pick an arbitrary one that you kind of like to work with, so whatever number is convenient. I don't know, let's pick -5, but this is going to be for this. Okay, so for -5, I'm going to substitute it back into here. So what do we have? So on top we have 5, so it's going to be 25 minus, so 5 times 7, and it's negative, so it's plus 35 minus 20. Okay, so all of that, so this is going to be positive on top, so the numerator is positive, denominator -5, and then -5 minus 10, so that's also positive. Okay, so it's positive on this side. So if it's positive, so that means it's greater than 0, right? That's what we wanted. So it works for that. All right, so now that we have that, okay, so we can take a look. I'll take a look at the next interval, which is from here to here. We know that at t is equal to 0, well, we have an undefined, right? Okay, so notice that the inequality would have been undefined, so we can't really look at that. So I'm going to take a peek now at the interval where t, okay, so it's going to be less than 0, but it's going to be greater than this -2.17. So I'll just pick a convenient number again, so let's pick it at -1. So that's in that interval, so that's what I like to do. Okay, I'll get rid of this, and now again, so we're going to take a look at, okay, so what is happening to our numerator and denominator. So let me copy, maybe I'll paste it down here for myself, just to keep looking at it. So if I substitute -1 in here, so notice I'm going to get 1. So this is actually going to turn positive, so plus 7, minus 20. Okay, so notice that this is going to be now negative. So it's going to be negative in the numerator, and then the denominator, so -1. So that's again still negative, so negative and the negative, which is going to be positive. All right, So this one worked for us, and this one also works for us. So that's another interval that this works. So that means for everything less than 0, so it seems to be working, okay, at the moment. So now let's continue on, okay, and see this interval right here. Okay, so from here to here. So what's happening on that interval? So now again, I can pick a convenient number. I'll pick 1 this time around. So for 1, we're going to get, okay, if I erase this, see what happens to the numerator and denominator. So 1, now it's going to be minus 7 minus 20. So this is still negative. All right. And then 1, and then 1 minus 10. So unfortunately, it's going to be so positive, so and negative, so that's negative right here. Okay, so now that's going to be positive, and actually this brings me back, so it looks like I made an error there. So for this interval between t, so it's greater than this but less than that, okay, so I think this interval I made a mistake, the previous one. Let me redo it. Okay, so for the -1, I'm going to go back in there. So that's going to be 1 minus, so plus 7 minus 20. So indeed, that's negative, so that's fine. But the bottom one, negative, and then that's -11. So that's going to be positive. Okay, so I did make a mistake. So that means it's negative on this interval. All right? And then it was positive. So that means this one won't work. So that's fine, that's fine. And now again, you can do the same thing. So you can take this interval, this tiny, little interval, and then take this interval and then see what happens there. So I'll leave that for you to check, and I'm going to cheat. Okay, I'll put it into Desmos to see it. So let me pop up Desmos. All right, so here's Desmos. Let's put all of this junk in here. So I'm going to have, so I'll put X instead of the t, so Desmos right away starts plotting this for us. So t minus 20, so we have that all over. And this is going to be t, and t, t. I said x and I'm putting t in, and I have it in the numerator, so I'll change that. So we have that, okay. And let me check, change this to x. Okay, so we have that. Now what we wanted was, this was supposed to be greater than 0. Okay. Now let me get rid of this. Okay. So notice, so indeed, so we had, so within here, so that -2.17, so that's what it was on the left, so it worked. Then between -2.17 and 0, notice it doesn't work. You have that empty there. Then from 0 to that 9.17, so we said it worked, and indeed. And then those last two intervals, so these intervals right here, okay, between 9.17, so it looks like it doesn't work there, okay. And then for the last one, which is beyond the 10, okay, it looks like it works. All right, and you can certainly plug it in and check it. So we solved our inequality, all right. So it works for those 3 ranges. Okay, that's it. Pretty torturous test. If you actually did it correctly, it probably would have taken you quite a bit of time. Okay, thanks for watching. I hope that these questions helped you. Okay, cheers everybody. Bye.